Okay, this is a video for a previous video on 6.1 notes that I found an error in. So let me start out here by saying that in this section, this is 6.3, we're going to prove that triangles are similar by AA, and AA means angle, angle. Okay, in terms of vocabulary, similar polygons, we know, have the same angles, so that means the corresponding angles are identical in size, and the sides are not identical. They're different, but they are in proportion. So we had learned that previously, so that's just a continuation of what we have done. So let's look at this postulate. This postulate is the angle-angle similarity postulate, and it says if you can prove that two angles of one triangle are congruent, and notice I'm using the congruency symbol right here, not a similarity symbol. So congruency means that they're exactly equal to two angles of another triangle, then the two triangles themselves are similar. So for example, this J has a double hash mark, X has a double, K has a single, Y has a single. So because I find that this angle equals this angle, and this angle equals this angle, I have angle-angle similarity, and I can say, here's your similarity statement, JKL is similar to XYZ. And that means that angle J equals angle X, angle K equals angle Y, and angle L equals angle Z. Once they're similar, remember you have proportions of sides. So JK over XY equals KL over YZ equals JL over XZ. Okay, so all those things are happening. So that's kind of a review of what we've done in 6.1, but now we're able to prove things by only having two angles equal. Okay, let me slide down here. Here's example 1. We want to use the angle-angle similarity postulate. So when you see triangles like this, and you look at the angles, 90 equals 90. Okay, 64 doesn't equal 26, but you have a missing angle in both of these triangles. Solve for your missing angle, just like I've said here. You know that inside every triangle you have 180 degrees. In a right triangle, the two non-90 degree angles are complementary. That means that they add up to 90. So 26 and 64 add to 90, and 64 and 26 add to 90. Now I have two identical angles, 26 and the right angle, 26 and the right angle, or you could have said 64 and 26, 64 and 26, or you could have said 64 in the right angle, 64 in the right angle. Any of those combinations get you angle-angle similarity, and you can use that now to write your similarity statement. Okay, moving down to number 2. So what I see here, it says that show that triangles are similar. So example 2 says, show that the two triangles are similar and write a similarity statement. Okay, so here's a little triangle on top, and then here's the big triangle. Okay, so what I'm seeing is this. This angle A is shared by both the little triangle and the big triangle. That's an angle in common. Then I have 52 degrees for this angle right here, and 52 degrees for this angle right here. That brings me to angle-angle similarity. So you can say that the big triangle, which is DAC, is similar to the little triangle, EAB. Here's your similarity statement. Moving on to the second example. Remember in previous sections, if you have vertical angles, they're not going to mark them equal, but you need to know that you must mark them equal. So here I've marked the vertical angles equal, and now I have a parallel line here and a parallel line here. This is acting as a transversal. So over here I drew from chapter, I think it was chapter 3, we had parallel lines and alternate interior angles equal. Well, these guys, S and U, are alternate interior angles, so they are equal. That gives us angle similarity between the two shapes, the two triangles, and I can write R SV is similar to T U V. You've got to make sure you line up the correct angle. So U has a double hash mark, and so does S. And then R is unmarked, and so is T. And V are the vertical angles. Okay, let's continue. Here's a standardized test prep question. When they talk about these shadow problems, okay, so you have a shadow, what you're seeing here is that the flag post casts a shadow that is 54 feet long. So here's the flagpole. It is perpendicular to the ground, therefore I have a right angle. Here's the shadow, and then connect these two edges to close the triangle. Here is the woman. She's 5 feet tall, and she's standing perpendicular to the ground, which means you get a right angle, and here is her shadow. Okay, what you need to know is a couple of things, and I had found an error in this earlier, and I didn't fix it, so I'm going to fix it now. So the whole thing about these two shapes is as follows. You have a little environmental science going on here. And up here in the corner, you have a nice sun. Okay, so the sun is casting its rays. This is what's causing the shadow. Okay, so here's my sun's rays. Because the sun is at a certain angle in the sky, this angle and this angle is going to be the same. So I have angle, similarity. Now this, I don't like the way I did this, so I'm going to change this up. I want to say x is to 5, so I don't want to have that be 54. So let me just do this. I'm going to erase this 4. So just don't even write it down. Okay, x is to 5, just like 54, now that's correct, is to 6. So what's 5 times 54? Well, 5 times 4 is 20. Put down the 0, carry the 2. 5 times 5 is 25, and 2 more is 27. So if I'm doing cross product, so here I'm going to change my color. Okay, so I have this. 6 times x is 6x times this. 5 times 54 is 270. Go ahead and get your x by itself by dividing both sides by 6. And 6 goes into 27 45 times. So my x, that's the height of this flagpole, is 45, and my units were feet, so it's 45 feet. Okay, make sure you write that down, because as soon as I go down this page, all the markings will go away. Okay, you can freeze the video if you want, but I'm going to move down the page now, and that means that those markings will leave. Okay, so let's continue down this page. And here's some extra practice. So it says, determine whether the triangles are similar, and if they are, write a similarity statement. So you have a situation where you have missing angles. This is 53. This angle plus the 53 has to add up to 90, so that 90 plus that 90 is 180. This 37 and this missing angle have to add up to 90, so that the triangle has 180 degrees inside. So when I do the math, I find that this missing angle was 37 over here, and this missing angle was 53 over here. So what's going to happen is this. I am seeing that I have angle-angle similarity. How do I know that? So I can turn my marker on again, and I have this angle matches this angle, and let me pick the 37s. This 37 matches this 37. So write your similarity statement based on angle-angle, and you get x, y, z is similar to a, b, c. And there you have your similarity. Okay, so I'm going to slide down the page, and when I do that, the ink's going to go away. Okay, there's another practice problem, and here it is. Show that the two triangles are similar and write a similarity statement. So, here you have vertical angles. Mark them. They're never going to mark them for you. You have to mark them. With parallel lines, I also get these alternate interior angles. So I now have, grab my pen again, I have angle-angle similarity because I've got this angle equals this angle, and I have this angle equals this angle. So I had vertical angles here and alternate interior here. So write your statement, EFG. So I went from the single hash mark to the vertical to the unmarked. Single, vertical, unmarked. That's my similarity statement. This is another example of having this common angle and then another angle that was identical. So I can say that this top baby triangle, which I'm going to label as PQR, that is going to be similar to SQT due to angle-angle similarity. Okay, and I think I have one more practice problem, so let me go down and see if I can grab this. Okay, so hold on. Pull this down just a little bit. And I thought there was a question 3, and there is, but let me just get to it. Oh, here, hold on. So sorry. Okay, I have to slide up now. Okay, so let me grab this, because this jumped last time. We didn't want it jumping around this time. So I'm just going to slide back up to this last, here's that last problem, right? I was doing this one, I'm now doing this one. Okay. Here is your famous shadow problem. So a school building casts a shadow that's 26 feet long. At the same time, a student standing nearby who's 6 feet tall casts a shadow that's 4 feet long. How tall is the building? Okay, once again, I've messed up these proportions, so I'm going to change this up. So you're going to make the changes while I do it in front of you here. So I'm going to say x is to 6. X is to 6, so get rid of this 2. 2's gone. Just like 26 is to 4. Okay, so now that we fixed the fraction equal to fraction, here are your cross products. So 4x is going to equal 26 times 6. Do that math. I've done it for you over here. I get 156 equals 4x. Divide both sides by 4, and I have found the height of the school building to be 39 feet. So write this down, because once I get off the screen, all the ink's going to go away, and then you should be all set to be able to do the homework problems.